So here's our second question. So in grade 11, you always had forces acting like left or right or up or down, but now we're looking at what happens when we have forces at angles. So in this case, we have a 10 kilogram block placed on a surface. We're first going to look at what happens when it's frictionless, and then we'll see what happens on a table that does have friction. So we have some object on a surface. It is 10 kilograms, and a person pulls the blocks towards them with a force of 40 newtons, 30 degrees above the horizontal. So let's draw our free body diagram. Let's make sure we know all the forces acting on this. So someone's pulling it upwards, so we have that's at 30 degrees, and we're pulling with 40.0 newtons. Also acting on this box, we know there is force of gravity acting downwards. And we know that when anything is resting on some type of surface, there is something called the normal force. That's preventing it from falling through the ground. So it's that reaction force. The block pushes down the ground pushes back up on the block. And if that normal force was not there, it means that the block is going to be falling through the table or something. One thing that's a little bit tricky to note is that in grade 11 we always stated that force normal is equal to force of gravity. However, that is not actually true. We cannot just assume that the normal force is equal to force of gravity. The reason is because in this situation, for example, you're actually pulling upwards slightly. So you're actually, the person himself, by pulling upwards, is easing up on that force on the table. So it's reducing the normal force by pulling upwards. If you're pushing down, for example, think about pushing a lawnmower, you have a downwards and sideways force, you're actually going to be increasing the normal force because you're increasing the force against the ground. So just like in kinematics, we want to look at the sum of the forces in the x direction and the y direction. Okay, so we can look at what is happening in the x direction. So in the x direction, now the sum of the forces must equal to ma. Looking at the x direction. So what we do is we always start with this expression, F equals ma. This ma represents what's the overall effect that's happening on this box. We have to ask ourselves what individual forces are causing this acceleration. And when you look at this, there's only this 40 newtons pulling to the right. So we actually only have the only force acting in the x direction is this 40.0 newtons. But we just want the x component of that. So that is actually going to be cosine 30 degrees. So we can actually go ahead and solve for the acceleration right now. The object that is accelerating is 10.0 kilograms. That's multiplied by a. And 40 cos 30. That comes out to be 34.64 newtons. Divide that by 10. We find out we have an acceleration of 3.46 meters per second squared. So that's the answer to part A. Part B, it says, what is the magnitude of the upward force Fn exerted by the table? To find that, we have to look at the forces in the y direction. So I'm going to write out sum of the forces in the y direction is equal to mass times acceleration. And if we want to be more specific, and the x, that's in the x direction. This is in the y direction. And we're going to ask ourselves what forces are in the y direction. So we're going to look at our picture. You can easily see that Fn is pointing up. So I'm going to write down Fn. And then I think of what other forces are acting upwards. what we need to recognize is that 40 newtons is up and to the right. So if that was some force, we can call that's force y. This is going to be force x. You say, okay, Fy is also pointing upwards. But this is all being opposed by force of gravity. So now we look at this next line and say, okay, mass times acceleration. Let's logically think about this question, like, is this thing going up or down, or is this moving side to side? So in this question, the box is actually only sliding sideways. It's not going up and down. That means the acceleration in the up and down direction is 0. So we actually have 0 on the left side is equal to our normal force. Fy is actually just going to be 40.0 newtons sine 30 degrees. And Fg is just mass times gravity. So we can now solve for Fn. We get Fn is equal to mg minus the 40.0 newtons sine 30 degrees. So Fn is equal to, that's 10.0 kilograms multiplied by 9.81 meters per second squared minus 40 sine 30, that's just 20.0 newtons. So you get 10 times 9.81 minus 20, 78.1 newtons.